So it's Sunday evening, and you're sitting on your couch watching the news, and you see a news headline about a big breakthrough in stem cell therapy, stem cell treatment. And, you live in America, and the FDA comes out and warns against getting any stem cell treatment therapies as they may be unsafe and illegal. And you ask yourself, what actually is stem cell therapy? And is it good, or is it bad, or is it really the miracle cure that some people say it is? Well, let's talk about the science behind that.
Welcome to The Science Behind That with Atticus Hamilton.
Hello, everyone, and welcome on back to The Science Behind That podcast. I am your host, Atticus Hamilton. And on today's episode, yes, we're going to be talking about stem cells. And, this is going to be a very fun episode, at least for me. I hope it's fun for you because I'm probably going to get into a rant here and there about the political environment surrounding the science. Because, for those long-term listeners of this podcast, as you know, unfortunately, there are a lot of things in this world where the science becomes like kind of an oversight, and people no longer start making decisions about things based on the science and instead make decisions on things based on their emotions. And you guys will know, if you've been listening for a long time, that we have covered a lot of those topics on my podcast. But before we jump into today's episode, I'd like to invite all of you to go grab yourselves a nice hot cup of coffee, add a wee bit of maple syrup in it, and let's jump right into it. And one other thing too, before we jump right into it, if you listened to Monday's episode, you will know that unfortunately next week I am gonna have to take the week off because I've run out of time on my podcast hosting platform, service, whatever you call it. So because of that, I'm gonna have to take next week off, and also this episode is gonna have to be shorter than 27 minutes because that's all the time I have left for the next 7 days to upload an episode. So sit back, relax, and let's jump right into it. So today we're talking about stem cell therapy, as I already said like 5 times. But before we can really talk too much about it, I think it's important that I first lay out to you the 3 different general classes of stem cells. Because if you just Google this online, you get a lot of weird random results or whatnot. And so here I'm going to outline what the 3 general classes are. So the first one is totipotent stem cells. Now, totipotent stem cells you may have heard as embryonic stem cells. And these cells are probably one of the most awesome cells in the human body, in my opinion. And they're found in the embryo during fetal development. And they're called totipotent because these cells can literally become any type of cell in the human body, any type of cell. And you can govern that. That is not just based on genetics. And in fact, with a lot of stem cells, there are very little genetics dictating what they will become. Usually they become what they become due to different hormones that are secreted or cell signaling molecules that are produced by nearby cells that then stimulate which genes they'll start to express. But anyway, so totipotent are also known as embryonic cells. They have a high potency, which means that, again, they can become pretty much anything, which is so cool. And you can find them in the zygote and early morula stage of the development of an embryo, of a human embryo. And it's really cool because they're also really easy to isolate, obviously. They're really easy to grow, and they have just a massively wide range of application in medicine. However, and I know a lot of you viewers are from Nordic countries. Only one is from my home country of Sweden, which makes me a little sad. But a lot of you out there, if you're not from the US, you're either from Denmark or Australia. And so, this may not apply to you, but here in America, it's kind of unfortunate because there's not a lot of research that's allowed to be conducted on embryonic stem cells because of a very vocal, lobbying agency of people who think it's immoral. I, of course, think that's stupid, but, I'm not the one making decisions on the high levels of government, unfortunately. But, and it's really too bad because there are a lot of great applications that we could use totipotent stem cells for. Here in America, the research isn't banned outright yet, but it's definitely looking like it might end up going that way, unfortunately. I know some states have tried to enact their own bans on stem cell research, which to me is again, stupid. It's in my opinion, banning stem cell research would be the same thing as if agencies banned cardiovascular research in the 1960s to prevent people from doing heart surgery. Now I say that, but again, in the U.S., heart surgery was definitely frowned upon up until the 1960s for other stupid reasons. But anyway, that's something for another episode. So you have totipotent stem cells, then you have pluripotent. And so pluripotent stem cells are like a medium potency. And these are also called embryonic stem cells, but they are... So while both totipotent and pluripotent stem cells are both taken from the fetal development stage, totipotent stem cells are taken from either a zygote or a morula, and pluripotent stem cells are usually taken from a more developed embryo themselves, and you can also induce them in other cells. So you can kind of create pluripotent stem cells artificially, or you can take them from the inner mass of the blastocyte. And so pluripotent stem cells, they can't become anything, but they can differentiate into any cell from any of the three germ layers. So the mesoderm, the endoderm, and the ectoderm. So they can develop into any of those cells. And in human developmental anatomy, every cell in the body comes from one of those three layers, kind of. There's maybe one or two exceptions, but at least all the organ structures come from one of those two layers. So just in a very brief overview then, the ectoderm gives rise to the nervous system and the epidermis. And so that one, when I was studying anatomy, was always confusing because ectoderm is the outer layer, right? And so it's like, why does the ectoderm give rise to the nervous system along with the epidermis? But it's because during the development, a portion of the ectoderm kind of folds in on itself, and those cells that fold in become the CNS, the central nervous system. And it's kind of a relic from our ancestral cellular development, where very, very early vertebrates had what was called a notochord, and development was very similar. Anyway. And so the mesoderm then gives rise to the muscles and the connective tissue of the body, and then the endoderm gives rise to the alimentary system, or the gut, and the internal organs. So just as a review, ectoderm gives rise to the integumentary system, which is the skin and the nervous system. The mesoderm gives rise to the articular system, which are the muscles, bones, and ligaments and tendons of the body. And the endoderm gives rise to the alimentary system, and then other viscera. And alimentary is going to be your esophagus, your stomach, your intestines, etc. And then it also develops other organs, internal organs. And so pluripotent stem cells then come from one of those three layers. And so a lot of times when people talk about embryonic stem cells, usually they're talking about these pluripotent stem cells, or IPCs, induced pluripotent stem cells. But I don't know. I guess it's kind of semantics. Totipotent and pluripotent technically could both be embryonic stem cells because they both come from the embryo, just different stages of development. But anyway, multipotent then is the third class. And the relative potency of multipotent stem cells is therefore very low because they're kind of restricted into what types of stem cells they can develop into. So my favorite cell in the human body is the mesenchymal stem cell. And the mesenchymal stem cell can pretty much become any cell within the articular system, or the mesoderm, right? So that's going to be like muscles. It can become bone. It can become tendons, ligaments, and usually as you get older and, if you develop chronic illness, those mesenchymal stem cells turn into adipose cells, which is sad. But so generally that's what a multipotent stem cell is. It's a stem cell that's restricted to differentiation in at most one germ layer. So either the mesoderm, ectoderm, or endoderm. And there are some examples of stem cells that are not even able to develop into things that are in the same germ layer. So they're restricted to a very specific set of cells, like hematopoietic stem cells. Those are the blood cell progenitor cells. So they can become erythrocytes, they can become leukocytes, they can become lymphocytes. So they can become red blood cells or white blood cells, basically, but nothing else. So, and of course, neural progenitor cells can become neurons and other types of neuronal cell structures. But they're in pretty much, you can find at least one type of multipotent stem cell in pretty much any tissue in the human body, depending on the age of the patient. Again, there is a point where they kind of, go away, which is sad. But they're very limited by their genetic expression. So because of it, and because of the fact that just generally they're pretty scarce, it's hard for people to be able to isolate them and, utilize them. So anyway, continuing on. So how does then stem cell therapy work? Well, it depends on really what you're looking at. So there's a lot of research into just using embryonic stem cells and just kind of haphazardly injecting them into the human body, and they'll go to where they need. They'll go to where they need to be used, which it's not inaccurate, but it is kind of silly, right? Because we don't know a lot about stem cells. And we don't really know a lot about, how they should be used for treating various things. And so by unfortunately just injecting purified embryonic stem cells into you, you're just kind of, throwing a dart at a dartboard blindfolded and hoping that something happens. And that being said, there is a lot of research that shows that despite, I guess, the crudity of it, it is beneficial. There's a lot of case studies of patients who had like Parkinson's disease in America. And in America, the treatment generally for Parkinson's disease is still pharmaceutical substances to regulate dopamine and increase basal dopamine levels. Because if you don't know, one of the big culprits behind the jittery movement of Parkinson's is inadequate dopamine production. Because your brain produces dopamine almost constantly because it facilitates controlled sort of fluid movement, right? And, when something happens or when a patient has Parkinson's, we don't really see that. And so there was one woman in particular, one case study in particular. She had Parkinson's disease. It was really severe. And with the cost of prescription medication in America, she felt like she had no choice. And then she learned about a stem cell clinic in Turkey, I believe it was. Maybe it wasn't Turkey. No, I think it was Turkey. And so she went to this stem cell clinic in Turkey, and they treated her with purified concentrations of embryonic stem cells, which I believe they used totipotent stem cells. And within a matter of months, her symptoms of Parkinson's almost completely disappeared, which in my opinion is amazing. And that really highlights the massive healing potential that stem cells pose. But of course, at least at this moment in time, there are no approved stem cell therapeutics in America. And so this is the part in the episode, ladies and gentlemen, where we kind of get into the politics of it. And, as you know, this is a science podcast, but sometimes, unfortunately, the science becomes corrosively, I guess, innervated with branches of politics and feelings that I have to talk about it. So if you just go to Google and you type in stem cells, you'll find a page here by the FDA, U.S. Food and Drug Administration, warning people against stem cell treatment in other countries. Now, before I say anything else, I do want to say it is very important to make sure that wherever you're going for your stem cell therapy, it is a reputable place. Okay, I mean, that is obviously very important to make sure that it's a reputable clinic and not just, Phil in his garage. Hey, I got a stem cell syringe here for you. You don't want that. But the irony here is that the FDA is warning against using stem cell therapy as it may be illegal and unregulated. And I say this is ironic because there's a company that has had a proposed medication under review by the FDA for stem cell therapy for over 15 years. And it was clinically tested in trials, and it was found to be effective with what they were treating, but the FDA has still refused to look at it. And that, in my opinion, is politically caused. The unwillingness of the FDA to look at it is due to the lobby, in my opinion, is due to the lobbying of certain agencies here in the U.S. trying to prevent any stem cell medication, stem cell therapy research or treatment from being approved. And to me, that's sad because the data shows that stem cell therapy has the potential to treat a variety of different things, from nervous system diseases to diseases of the articular system. I think for a lot of things, the key is within stem cells. And there's a lot of research to back that up. And so why am I saying this? I'm bringing this up because currently in the European Union, embryonic stem cell research is permitted in Ireland, Sweden, Finland, Belgium, Greece, Britain, Denmark, and the Netherlands. But if you don't live in one of those countries, it's not allowed. It's not allowed. And I encourage all of you to, I always say to stand up and question everything. I encourage all of you to not only do your own research about stem cell therapy after what I just told you. The whole point of this was mainly just to explain what stem cells are. But I also encourage you to, be very critical of why certain things are banned in your countries. And I say your countries because, again, there's a lot of you out there. I think I have a listener from almost from every continent in the world, which is amazing to me. And because of it, there's a lot of different laws around there. And so I encourage all of you to ask those hard questions. Ask your officials, well, hey, a totipotent stem cell is literally just a cell from a ball of cells. Why is it illegal to use? Or why is it, at the very least, illegal to do research with? And I encourage all of you to ask those hard questions. And they are hard questions. But in my opinion, from the research out there, the future of medical therapy for a lot of diseases is not just more drugs that suppress the symptoms. The future is stem cells. And it's just true. I mean, there's data to show that stem cells would be able to help significantly with Parkinson's disease, with celiac disease, with articular diseases like Lou Gehrig's muscular dystrophy. And the research out there is strong currently. Now, it's not a magic cure-all like snake oil, right? It's not a magic cure-all, but it has significant application. And at the end of the day, the goal of medicine is not only to treat illness, but to prevent illness. So, ladies and gentlemen, I really do hope you enjoyed today's episode. I'm quickly running out of time here. I hope you enjoyed today's episode. I will see you all next Monday, unfortunately. But until then, have a great weekend. Remember, have a great week. And I will see you all in the next episode. And remember, stand up and question everything.